in the foreground there, we have a butane oxygen flame and a hydrogen oxygen flame. So the question was, why do they have different colour? So we got the spectrometer in the background, and this is the spectrometer probe here. So the first thing I'm going to do is just go to a mostly sooty flame, and we should, a little delicacy here, raise the max out on the sooty flame. Get something that looks incredibly like a black body curve for the sooty part of the flame. And if you come down to the base of the flame, you get all sorts of emission lines, which I reckon are related to combustion products in one sort or another. Because the interesting thing is, if you make a note where those are, and most notably there's not one in the ultraviolet here. So if you come up and then start adding more oxygen till you get to the post-combustion flame, you've now got this guy in the infrared, and you've lost most of the other emission lines. Whereas if you actually come down to the base of the flame, you get all sorts of emission lines in there. Okay, let's kill this guy. So can we see the hydrogen flame? Out there is good. So you can see even from here, when I've not even got it very well lined, that there's a big ultraviolet line in the hydrogen flame. Right? And it's difficult to actually tell whether you're actually looking at the base of the flame or the post-combustion, but either way you've got, that's probably, if I had to guess, the one. Actually, I'm not so sure which one's giving you. So these are emission lines. So obviously, looks like you've got the sodium emission line there, and at some point, that's not unsurprising. Don't know what this guy is, but there's certainly quite a lot of ultraviolet coming off this. If I had to guess, it's oxygen. Anyway, so that's what the spectra of butane oxygen and hydrogen oxygen flames look like.